in the past, show a couple of videos and a few photos, get some of your input in our large group session here, and then we'll do our breakout rooms. I think we may end up, if it's manageable and we have a reasonable amount of people, we may just try and stay all together so we can, you know, get to know some faces from other classrooms that aren't in the car rider line. So thank you all so much for giving us some of your time tonight, and we're gonna get right in. I have another monitor over here, so I'm not staring off into space, but forgive me for any technical things. I've gone bold and done a PowerPoint today, so let me just fire this up. Share screen, screen 2. Kate, can you give me a heads up when you can see? Good. Okay.
All good.
Okay, so we're going to talk about the mathematical mind today. And we're going to start with what that is. What is mathematical mind? First and foremost, we may be disappointing you, I don't know, but what we're not talking about primarily tonight is formal mathematics. So that means we won't be talking about all of those things like numbers, symbols, operations, formulas, algebra, all of those things. Those things will come, but that's not the meat and potatoes of what we're going to talk about tonight. Rather, we're going to talk about discussing the concept of what that mathematical mind is in its most simple form. And then we're going to dive a little deeper into where this term originated and what it really means. The term mathematical mind, we know we're all Montessorians here, but it's not actually Dr. Montessori's own term. It was originally coined by Blaise Pascal, who's a French philosopher and a mathematician, and Dr. Montessori kind of borrowed the term in relation to her research and the observation of children that she was doing, and kind of applied it to what she noticed in our children in the Montessori environment. So the mathematical mind is most simply the innate tool that allows us as human beings to organize our world. Order and organization are natural instincts of man, and they bring clarity to us. In the beginning of humanity, man was kind of forced to observe and recognize patterns in order to be able to survive. For example, recognizing kind of passing seasons and weather patterns in the early days of humanity would directly influence our ability to survive. Observing things like, when do we eat fruit? Oh, okay, we have to wait till it's ripe. When does a new day start? Oh, when the sun comes up. So these are just patterns that man was kind of observing and starting to notice that they needed to adjust their behavior in order to be successful and thrive. Human beings are also unique, we know this, in our ability as a species to be able to pass on information from one generation to the next. So that means obviously through verbal language, but through written language as well. So because of our ability to do so, we've moved beyond this innate survival instinct of observing these patterns, and we've moved towards a more analytical awareness of the world. So we're able to take information, pass it on, and become a little bit more conscious with each passing generation. So Dr. Montessori recognized, as did Blaise Pascal and all those who have explored the mathematical mind, that all babies are born with mathematical minds. So that means that they have a propensity to learn things. The chat. Okay, thanks, Kate. Okay, can you see?
Yeah.
Okay, good. So the mathematical mind, it means that all babies have a propensity to learn things, which enhance their ability to be exact and orderly, to observe, compare, and classify. Unlike the absorbent mind, which we know because we've talked to you about it so much, that occurs in our children that are from 0 to 6, that only exists for that 6-year period. The mathematical mind remains active from birth all the way until death. But we recognize that the marriage between the two is really the magic of our first plane child. We are able to understand that the mathematical mind can work in conjunction with that absorbent mind. So the like bold italicized thing that we want, one of the things that we want you to take away is that the mathematical mind helps that absorbent mind classify and organize the information that is constantly being absorbed. So we know that they're a sponge. We know that they're absorbing everything that's around them, their language, their materials, their all of those things. But that mathematical mind is working together with that absorbent mind to be able to rapidly kind of classify, organize, and recall all of that information. However, we also recognize that the vital part of intelligence has to be given help and direction for it to develop and function. So, you know, in our perfect, big air quotes, environments, we're able to support the child under 6 who is kind of on this journey with the mathematical mind and the absorbent mind. So like I said, the mathematical mind gives the spontaneous ability to organize, classify, and quantify patterns and relationships within the context of daily experiences. This is how we learn. So we first search for contrast. We want to find something that's the most different, the two things that are most opposing, and that helps us to understand quickly whatever the concept is that we're looking at. Once we've found that great difference, we can then begin to start classifying and organizing things rapidly in our brains within that context. So this is the foundation for many things. And it's also how we're able as humanity to begin to make inferences. So for example, to use the early humanity kind of example, at that time when they were observing, they might have been noticing, okay, daytime versus nighttime. When the sun comes up, you know, that's when the day starts, and when the sun goes down, that's when nighttime is, and that's when we sleep. Those are the kind of the most contrasting. Then they get to the point of weather patterns, so they can recognize, okay, you know, in Canada per se, at this, you know, within this 3-month period, that's when it's going to be warm, so we need less shelter or less clothing. And then when it gets to those colder months, we need to kind of hunker down and be aware of our environment so that we can be healthy and survive and all of those things. Fast forward to kind of the more classification in between those two kind of polar opposites is when you can start to make those inferences. So for example, we're now at the point where we can look out the window, we can see the sky, and we can say, oh, the sky is gray. So my inference is maybe I should bring my umbrella with me today because perhaps it's going to rain. That's a very different thing than like daytime wake, nighttime sleep. So we have a little bit more information. And again, we recognize that the mathematical mind is obviously very closely and inextricably linked to math as we know it, but we also want to think about what that mathematical mind allows us to do outside of, you know, adding, subtracting, multiplying, and all of those formal mathematics terms. We've talked a lot about it and how it kind of relates to our children, and when we talk about goals for our children, this example kind of came to mind. We were discussing and said, a person who's able to hold a really beautiful conversation has mastered the exact science of giving and taking. So that person can contribute and they can listen. To achieve that perfect conversation, I'm sure we've all had one before, that is the example, that's a perfect example of that mathematical mind at work. Okay, so that's our little, what is it? Okay, great. So now we're going to say, now what? We've kind of broken it up into 4 subheadings, so we can talk a little bit about how this information applies to what we do at school and kind of give you some thoughts or some ideas about what can happen at home in order to support this mathematical mind. Starting with logical sequencing, then we're going to go to precision, talk about our pattern of presentations within our environments, and then get to making some distinctions. So, okay, so logical sequencing. In our environments, in the Montessori Casa environment, children are shown materials that require logical thinking and a sequence of steps. So doing these activities that have logic sets the child up to understand that there is logic and sequence is important. The setup of our materials matters. We know we've talked to you about this a lot, but it's very applicable and we see it every day, and it's very important that, as you can see in this one little picture here, this is polishing glass. So from left to right, we always want it to be left to right because that's how we read and that's how we write, of course. But when the materials are set up from left to right, it allows the child to become much more independent so that they can sequence through whatever their task is. So on the left, that's the little polish. In the middle is the dish with the sponge, which they will use. This sponge will be damp and they'll use that to apply the polish. And then the third step would be the little cloth there that they use to make a mitt around their finger so that they can remove the polish. And then, you know, their cleanup is similar in a similar sense. But the general purpose of this sequence is that they can move through the steps of the activity independently. And it gives us kind of the ability to observe and recognize, okay, are they able to identify what comes first? Are they able to identify that something happens in the middle that's significant? And are they able to get to some kind of an end result that's fulfilling for them? When they're showing us that they're not necessarily setting up a material from left to right, perhaps maybe we need to represent just the setup part of that material, which is fine. But sometimes their sequencing will be that they can make sense of what the presentation was. So if this child hadn't set it up from left to right, but they were able to recognize, okay, I got to go dampen my sponge, otherwise this isn't going to be successful. And then, oh, my polishing cloth, I tried to wipe off the polish before it was dry, so it's not working. You can still, through our scientific observation, we're able to observe and see they may still be sequencing even if it doesn't look as perfect as it does on the screen. But that's just a nice example for you to see kind of something in our environment that allows them, that sets them up to be successful with that logical sequencing. I have some more photos. Let's see. Okay, so as you can see, I've already shown the polishing glass photo, but next to it, this green material here is polishing wood. So you can see there's quite a leap between these two things. We have 3 little steps in polishing glass, and then we have extra steps in polishing wood. So once the child has shown that they can logically sequence through polishing glass, then we can go into something like polishing wood, which has, you know, the little polish bottle with a little dish and sponge like before. But now we have 3 separate cloths, and each one of those cloths has a different purpose. We have a meaningful conversation with them in that initial presentation, where we're able to say, you know, this is our thin cloth, this is our rough cloth, this is our soft cloth, feel it, and give them kind of that sensorial experience. And then each cloth has a separate purpose. So they each make a slightly different mitt, and the purpose of the material is much more in depth than it would be with polishing glass. So again, this is just information for us as guides in your children's lives. But when we introduce them to something like polishing wood, we're able to watch them and see, you know, we're asking ourselves constantly, are they consistently missing a step? Is the work successful without that step? So for example, if they were washing a table, which is this bottom material here, that's the bottom picture here. If they're, you know, trying to apply soap without adding any water, it's not going to lather, so the material just isn't going to be successful. It's not going to give them the response that they need. However, you know, something like whenever they use a jug in the classroom, we show them to, with a sponge, wipe the lip of the jug so that they don't drip on the floor. If they're missing that step, they might have a couple of drips, but ultimately they're going to be able to clean it up and still be successful. So we're observing to see, okay, is their logical sequence there? Can they navigate this material with logic? And if not, like, what is the hole that's missing here, and how can we support them to get to mastery of that material? We're asking ourselves all the time, are they able to follow the purpose of the material with the materials alone? So without our intervention, we always, you know, give that initial presentation, but are they able to recognize what the material is calling within them? The materials are set up in a way that everything that they will need to perform the task is there. That being said, you know, if a spill happens, that logical sequence might be, okay, I was washing this table, I kicked over the bucket, oops, now I have to go into the kitchen or go into a different space in the classroom, get my spill bucket, and that's a whole other logical sequence of events. But within their work, they're able to recognize kind of an if-then pattern. And we're able to observe, you know, sometimes they're not going to get it all the way dry, that's fine, but we can see that they're able to kind of navigate those big big steps in order to be able to be successful. We're also asking always, were they successful on their first attempt? So if I present something in our environment and the child instantly has the ability to go through the entire thing, the first question that I'm asking myself is, why did I wait so long? That is my failure. I should not have waited for this child. They're clearly there, and we want them to not be successful their very first opportunity, because we want them to be able to reach that point on their own. And then we're asking ourselves, you know, oh, they're friends with such a buddy person, they've been shown that, perhaps they've been observing another child work with that repeatedly. Great, all of those things. But moral of the story is that when we're observing logical sequence, we're always asking ourselves these questions, and we're determining whether we need to represent and whether we present it too late, and all of those other things that we're watching for. I have some videos that I wanted to show you, but I wanted to kind of invite you, as I show some of these videos, to think a little bit about, these are some of the materials that you see in these photos being used. And also Delta from Casa East has sent me a photo of one of her children doing washing linens in the classroom. So knowing now what we kind of know about the mathematical mind and those observation questions that I've posed or let you know that we look for all the time, I wanted to show some of these videos and then invite you to think, as you're watching them, about, okay, is the purpose of this material being met? You don't need to know the purpose, but does it look like something is being met here? When a problem arises, is that okay? Why not? Why or why not? And also just watch these lovely children working hard. It's nice to see. Okay, so let me know. Okay, so I'll start with a washing linens. Can everybody see it? Yeah, okay.
No, I got them, so you don't need to take this one. I
Yes, my first time.
Don't do that.
Okay, so having watched that, does anyone have anything that kind of stands out? Anything that you recognize that was that logical sequence or that order or her thought process? Did you think it was great? Did you think it was terrifying to watch her maybe knock all of that stuff over? Okay, everybody be quiet. Shh, 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 shh. Okay, I'm going to show you another. I think Steph and Ryan are here. We're going to see Amelia in action. Okay, so we can see in this video here that she is clearly concentrating. She's really focused. We're seeing a little bit of like sink and float exploration. She's looking at that sponge and thinking, what's going to happen if it's full of water, if it's not full of water. You could see her like much of that video that's almost 2 minutes long was her just kind of being grounded and centered with the materials that she had. And then when I like zoomed over a little bit, you can see like, oh yeah, that table is full of soap. She clearly got the.
How long did it take to clean that table?
How long did it take for her to clean the table?
Yeah.
Probably. I mean, this is a longer material. Like you can see that there are more materials and there's 3 multi-steps. So I mean, the whole start to finish process here was probably like 15 minutes. That's like a pretty long extended focus. We've seen, washing table can last for the morning, and we've also seen it go pretty quickly depending on if they're really engrossed in what they're doing. But she was fiercely determined to get it done and do it her way, which is the way that she is. But it was beautiful, like such a beautiful thing to watch and see her go through all of those steps. I'm sure that the other guides noticed, but part of the mathematical sequence, so to speak, of something like washing a table is that we show them to fill the jug up only one time, and then they have to reserve the water for 3 different steps. So they use the water in the bowl to wet the table, and then they can lather out the soap, and then they use it at the step that she was on right now to remove all of the water, and then they empty it into the bucket, as you can see. And then the final step of that last third of the water is to clean their materials and get all the soap off of the brush and those kinds of things. So we're constantly observing to see, are they able to segment it? Like oftentimes we will see, oh, they've overfilled their basin with all of the water. And that's just information feedback for them. So, okay, next time I'm going to need to reserve my water. Otherwise, I'm going to have a spill, or I'm going to run out and I'm going to have to go and revisit the sink, et cetera, et cetera. So she, in that particular video, she did reserve like water for a second step. So that's information for us that she was able to understand that there's more to it than just getting the table clean. And then I think, oh, I have this one as well. So we'll watch Sabine. She's squeezing a sponge from yesterday. lots of really beautiful things that were happening in that video, but some of the standouts that I observed were the amount of times that she recognized that she was getting more drips when her bowls were kind of slowly separating. So like constantly stopping herself to put them back together. And in the presentation, we showed them to sponge or to squeeze all of the water from the left bowl into the right bowl, and then empty the water into the sink, and then use the cloth to wipe out the bowls to let the material be ready for the next person on the shelf. We regularly see with this material, they just kind of squeeze back and forth, which is beautiful repetition, and it's strengthening their hand and all of those beautiful things that we know that Practical Life gives to them. But yeah, it was beautiful to watch her, figure out and logically deduce the table is wet. So I'm going to stop and I'm going to wipe the table as I go. I'm going to put my bowls back together. So all of those things are that mathematical mind at work. I have another one, but I'm going to do a little bit more talking before we go on. So, okay, so we're going to go into precision now. Precision. So the act of precision is critical as the child develops their mathematical mind. If the materials are haphazard, the child isn't being exposed to the intended impression of the material. So we recognize that, like I said, when we're setting up our materials, everything is purposeful, the way that we set it up, everything is exactly as it's needed. There's nothing that's, meaningless in their work. But we also, like I said before, we don't expect them to arrive at this precise work the first time that they work with it. We want them to be able to repeat to the point of precision. So the picture that's on the screen right now are the red rods, which are a sensorial material in the classroom that gives the impression of length. So the top picture is kind of maybe sometimes what they might look like when we first see a child taking them from their shelf to the mat, kind of haphazardly built all over the place. And the bottom picture is how we would present it as an initial presentation. So we show them to build them from longest to shortest, lined on the left. And the impression that we're trying to give them is that of length. So we're trying to show them that, the longest rod feels the longest, and then it's going to go shorter and shorter and shorter without the language, just so that they can get that initial impression of what an abstract concept like length feels like. I'm going to show you some photos just so that you can see. These are 4 different ways that we might see the red rods be built in our classroom. So top left is what we would show it as. And I just want you to just take a moment to think about it and ask yourself, knowing that the purpose is to be exposed to and to experience the abstract concept of length, which of the following or which of the other photos would be acceptable? Which of the following photos, they're all acceptable. Which of the others would be something that you might correct, or something that you wouldn't correct, or information that you would store? I'm not going to call on you because then I have to stop sharing my screen and I can't see anything. So if anybody has like anything really dire that they want to share, feel free to speak up. But as I'm sure you can imagine, the answer is.
Yeah, I find it really cool that, sorry, I'm driving, okay. So it's a little hard to follow along, but yeah, I find it really cool that there's different interpretations of it, right? That, the left and the right picture, or top left and top right, are kind of the same thing, just, the shortest to longest, the longest to shortest. But the one in the bottom left seems like a more creative mind, right? You're still figuring out your lengths, but you didn't conform to, the simple solution.
Exactly. Yeah, exactly. Yeah, that information, like the top right one, like you said, is like longest to shortest versus shortest to longest. It's really also the exact same concept, just aligned to the right. So we might maybe like observe and see, but if the purpose of the material is for them to be able to isolate and understand length, Bottom left, like you said, is just that child that's just outside of the lines and they want to be a little bit more creative, and or perhaps that's just how they've interpreted what the presentation was, and they're understanding that the long one goes up here and then everything else makes sense as it goes down. Bottom right, like I said, might be what it looks like the first time they use it, might be what it looks like as they're getting the rods onto the mat. If, it was the third time that they had practiced and it still looked like bottom right, we might just say, okay, I'll come and sit with you, and like, is it okay if I touch your work? I'm gonna have a turn, and then you can have a turn after, and kind of do that call of attention for that representation. But it's all a process. So what I had written before was that we have unspoken rules in the classroom as well that create structure and predictability and the opportunity to achieve precision in a different way. So for the child who, might feel like getting all of those red rods to the mat and then getting them back onto the shelf is a lot of physical work. Like it's I'm sure you can imagine that longest red rod is very tall, like taller than many of our children. So them carrying all of them over and getting them onto their mat is big physical movement. So sometimes, we might observe, okay, they're not revealing to us that they are capable of aligning them in some logical way or another. But then this is in Casa North in my classroom, but we have a stand where it's, graded so that they are aligned standing up, but they also, when they're on the shelf, if they're flat, they're still going to look like they did on the mat as per the presentation. So it's just information for us as well. Sometimes they're building them on the mat and it looks kind of like this bottom right, but magically in some way or another, they're able to get them back on the shelf because we have those unspoken rules that are, okay, I know I have to get it back on the shelf so that it's ready for the next person. Oftentimes we'll see, maybe that child's not mastered that yet and they're struggling to get it back on the shelf. And that's when we have that 3-year age mix where somebody that's older or that's experienced it already and mastered it might be able to come over and say, no, they don't go back in the stand like this. This one needs to go over here. And then they're getting that same experience, but in a different context, which is the beauty of our environment. I have this.
So it was just the pictures that I saw and I had no idea the scale. Like I honestly thought they were like pencils or something like that in the first picture, because I'm looking at my phone and I'm like, what? These things are like 3 feet tall. So
yeah.
That changes things a bit.
Yeah, they're mathematically graded. So that shortest one is 10 centimeters long, all the way up to 10 times 10 centimeters long, a meter. Okay, so, and then here's a photo of that's from Casa East as well. So you can see, again, we have like that triply creative child who has built them this way. And in our beautiful, authentic Montessori environments, we look at that and we see that that's beautiful. We're never going to go and say to this child, no, you're building it like the pink tower. It's not supposed to be stacked on top of each other, because this child has, creatively shown us that he knows what the concept of the material is, and he's explored with it in a way that has given him information and just beautiful work. Let me just make sure here. So yeah, just to wrap up the work with the materials in terms of precision, we want the child to have a deep and meaningful experience with their environment with these carefully constructed and accurate materials. When the child is free to repeat, he or she can refine their work, and then precision comes. Our environments are also prepared with unspoken agreed upon rules, like we've mentioned, and the unspoken rules, like getting the material back on the shelf ready for the next person, can sometimes help to refine some of those rough edges at times. Okay, so going on to the pattern of presentation in our environments. The general pattern of presentation in the Casa environment moves from the concrete to the symbol, and then later to the combination of both. So what does that mean? The concrete is a representation of a sensorial experience that the child will have. The sensorial experience has to occur first before we can give any language or symbol, and then the association of both of these together then comes later. So I have some photos to explain what I'm talking about here. So top left here, so these are the number rods. They're a very early math material in the classroom that are the exact same as the red rods, except they're segmented in blue and red segments so that they're able to be counted. So those red rods that we've been talking about before, once they've shown the experience of manipulating something by length and being able to order and classify them, and they've had lots and lots and lots of experience with that, then we're able to say, okay, here's these number rods. These are something very similar to something that you've worked with before. And now we're going to build them, and then we're going to count them, because that's something that is innately desirable to a child. They're always wanting to be counting. And then we've given them a sensorial experience of, as you can see at the bottom here, we do what's called a 3-period lesson. So 1, 2, and 3, we're going to count, lots and lots of counting, lots of manipulation, lots of repetition, and then they're going to eventually be able to recognize, okay, this is 3, okay, this is 2 on their own. So this top left picture, mastering the counting and manipulation of this material is a long process. We work with it a lot with the children. We really want them to have that solid foundation of what this material means and what the physical difference between 5, for example, can be versus 1. It feels different. It's not just so then when we move over to our sandpaper numerals, which is top right, after they've had some sensorial experience with counting and feeling those big things, we're able to go to sandpaper numerals. So this is where they're going to be tracing and learning what the symbols are, and we're not yet associating the two things together. We're just tracing 9, 2, 8. This is 9, say 9. This is 2, say 2. This is 8, say 8. And then, okay, let's put 2 over here. Okay, trace it. Okay, put 9 up in the corner. Show me where 9 is, point to 9. And then, oh, close your eyes. I'm going to remove 1. Okay, open your eyes. Okay, show me where 2 is now. Oh, 8's behind my back, giving them lots and lots of experience so that they can learn what those symbols are. And then the center picture is that association of the two. So that's when we want the two things to come together in perfect harmony, and they're able to start using those manipulatives together. So as you can see in the bottom, those number rods are out of order, and they are matching the cards that are the symbols that they will have known from the sandpaper numerals. And then there are a multitude of other presentations that we give with the number rods, where we give impressions of addition, we give impressions of subtraction. There's mat work. So there's mat work at a distance. So 2 mats that are on 2 separate sides of the classroom, and the child has to look at the card, hold it in their mind, and then go over to the other mat and collect the number rod that they're thinking of and come to associate it. So lots and lots and lots of repetition here, but the pattern of presentation in our environments is always going to be that we don't give them the language or the symbol of something that they haven't yet experienced in depth. Dr. Montessori uses the analogy of a tree all the time. She talks about how the roots need to go deep so that the trunk can grow, and then the foliage can be beautiful and healthy. And this work in the numbers to 10 area of our math in the CASA is the roots. This is the thing that there's no purpose in doing anything beyond this math work unless they have a very, very solid foundation here. She also uses the analogy of a ladder and says that the numbers to 10.
I'm gonna put Constance to sleep, and then I'll come get you. Okay?
The numbers to 10 work is like the bottom rung of a ladder. So there's no successful climbing of a ladder without that bottom rung. Okay, so our last little subheading that we're going to go through is making distinctions. So in our environments, we move, like I said, from highest contrast into kind of gradations between those contrasting things. And I've used this image here is color box 3, but I'll show another picture that compares all 3 color boxes, 1, 2, and 3, so that you can see the progression. We recognize that when we're working with materials in the environment, it's much easier to see something when it is highly contrasted. So for example, we also have a material called the Barrick tablets in our environment, where we have little wood tablets, and one is heavy, one is light. One is significantly heavier than the other. So the child will do this weighing motion, and they'll be able to blindfolded sort whether they're heavy or light into 2 piles from a mixed pile. We also have a third set of tablets that is kind of a medium weight. So before we would get them to sort all 3, we would do the highest contrast ones and then add that third one in that's kind of a middle weight to be a higher challenge and a little bit more of a minute difference. So it's much more challenging for the child. And then when we get to gradation with many of the things in the sensorial area and other spaces or other areas of our classroom, we always show, but when we're going to do a gradation of something, we show to isolate the 2 extremes first, because we recognize that when we see things visually, we first go to what's the most contrasting, and then we grade within them. We have a material called the rough tablets in our sensorial area, and it's little tablets that have sandpaper on them, and they grade in how rough they feel all the way up to something that's smooth. So we would always feel the roughest tablet and say, I'm going to put that here, and I'm going to find the one that's the most different from that, and then feel the one that's very smooth, put it on the other side of the table, and then we would say to the child, and now I'm going to grade them and just feel them, and then invite the child to feel our work too, so that they can have the accurate kind of initial presentation, and then they're free to explore with that and refine that on their own. So here we have colored tablets. On the left-hand side, this is actually 3 different materials. We just put it in one photo so it's all together. But on the left-hand side, where you see the blue tablets, the yellow tablets, and the red tablets, that's color box 1. So that is our primary colors. They are, on the color wheel, they're completely opposing. They are the most drastically different. And that's what we'll show first. And then we give the language to the child. Most children usually come in and they know those 3 colors. But then when we go on to color box 2, which is kind of this middle area here with the orange, pink, purple, green to brown, we continue to do the same thing where they're matching them all together, but that's the introduction of those primary colors and tertiary colors, which are a little bit less contrasting to the eye. They're a little bit more difficult to see or to isolate. And then on the right-hand side with these blue tablets, you can see that that's color box 3. So that's one where you can see at the top, it's the darkest, and at the bottom, it's the lightest. We don't give that language initially because, again, we want them to have a sensorial experience before they would be convoluted with language saying like, wait, is this dark? Is it light? Is it darker? Is it lighter? We would just put the darkest one up at the top and say, okay, I'm going to start with this one. I'm going to find the one on the table that's the most different from that, and then put the latest one down at the bottom and then say, okay, I'm going to grade them now, and then just grade them from darkest to latest. And that is obviously much more challenging to do than that initial color box 1 presentation. So why do we do this? What is the point? The results of these sensorial experiences is ultimately the acquisition of consciousness. So being free to interact with the materials sensorially and refine these skills helps the child to respond to many different situations. The child who's experienced a sensorial education does not rely strictly on his memory because he has perceived and experienced the material, and thus his knowledge is much more easily accessible in his mind. So when we're talking about that mathematical mind and being able to classify and order and make sense of the world because of those sensorial impressions, that's that absorbent mind and mathematical mind working together. It's much more easy for them later in life to recall things because they've had that deep and meaningful sensorial experience with it. We're not telling that information to them. They're feeling it, experiencing, manipulating, all of those things. So when we talk about practical life materials in the classroom, we talk about how those things are the purpose generally of practical life materials are for the child to control and coordinate their movement. So all of those things that they're doing, washing a table, washing linens, food prep, like all of that big purposeful, important work for them is ultimately helping them to control and coordinate their movement. They're going to refine skills and build skills and do all of those things. Sensorial and math, one of the most underlying purposes of all of those materials is that they're controlling and coordinating their mind. So we know that, not one thing is more important than the other in our environment, but but those are general purposes. We recognize also that the child will always have an opportunity in our environment to refine his movement, but that the mind and body are always working together. So we as adults have separated the areas of the classroom into the things that we talk about. I'm sure you've got tours when you first came to DVMS, and having lots of parent ed, you know that we have a language area, we have a math area, we have a sensorial area, and we have a practical life area. And all of those things are classifications that we have created as adults to help us make sense of our environment, set them up physically. We have done that so that we can record keep and we can lesson plan and all of those things. But really, all of those things are inextricably linked. So formal math cannot come without that sensorial enriched experience, without their work of that logical sequencing in practical life, without all of the things that we've talked about so far tonight. So the 4 areas of the classroom are as inextricably linked as the absorbent mind is with the mathematical mind for that first plane child. So that's most of what I was going to talk at you. I'm going to just put this up here, and I think I'm not sure if we're going to break out, but I've talked a lot about how we support the mathematical mind at school, and I've put a couple of points maybe for you to just think about if you wanted to pose some questions or ask us, pick our brains a little bit about how you can support things at home. We're always here, of course, but just to sum up quickly, at school, like I said, we have purposeful, beautiful, logical materials. We know that that's how the mathematical mind works. So we want our environments to be able to support those things without being barriers. So we set up our materials logically. We give a presentation. We don't make the assumption that a child can do something or understands the concept of something before they've had the experience. So I know I mentioned, like, sometimes we panic and say, oh, I showed this too late, but it's better to have given them the experience of having a presentation with something than it is for us to assume that they can do something that they've never been exposed to. So we give them that presentation. Non-intervention and observation, those next 2 points, you'll also see them on the at-home side. Those are probably, definitely, absolutely the most important things that we do in our work. We count to 10. We stop when they kick the bucket after they've been washing the table for 45 minutes. And then we cry a little bit, but we don't let them see it. And then everybody comes and helps, or nobody helps and they do it themselves. And the point is that we are there as a guide, but we are not there to intervene and do it for them. And then observation, like I said, everything that they're doing is information. So we try to view everything as a privilege or a joy, that when something goes awry, and today was a bit of a day where things went awry, it's just information for us. I several times today said to Paz, like, listen, I'm not doing anything. I'm stopping and I'm just looking and watching and seeing what's going on, because it's going to help me to guide them and serve them the best that I can. At school, we lean on our community, so that all of those examples about how, oh, I'm struggling with something, so I'm going to get an older child to help me with that. We really lean on community for natural consequences. So if something, doesn't get put back on the shelf, ready for the next person, it's not, you had your turn and now it's not fair for somebody else, or I can't think of another negative way of putting it. We just say, this is what we do. This is how we function. So can somebody help this person to get this material back on the shelf? Or can somebody help this person to open a jar because it's got oil on it from baking muffins, or whatever it is? We really lean on our community. And then representing, like I said, if we are observing and recognizing that they're struggling, we are always there to give them another experience with it at a time that might be better suited for them. And then at home, what are things you can do? So I've just kind of brainstormed some things. I know we talked a lot about how you can set up your home spaces. And again, we'll open it to you if you have any questions, but just think about, like, are they preparing their own food, for example? Are they contributing to dinner, or are they preparing their own snacks? If they are, is it possible for them to have, materials that are set up to be conducive for them to be successful and independent with those things? Again, if you have any questions about how to set that up, feel free to let us know anytime. Their playroom, are you doing a toy rotation? Are you finding that like the playroom is the bane of your existence and their toys are everywhere, and they can't logically sequence because things are a mess? How can we find ways for them to be a little bit more independent and kind of exercise those brain muscles? But obviously finding what works in your home. So making sure that whatever it is that you're implementing, you are giving yourselves grace and being able to still be joyful in your home and enjoy your children. Showing them how to use their things. So similar to the presentation in our environment at school, when they get something new, or if they're, using a serrated knife for the first time to open something, or to prepare their food, by all means, you're obviously going to show them how to use a knife, but you can show them, this is how I hold the knife so that it's a little bit more steady in my hand, and give them kind of an experience with what they're expected to do or what you're hoping that they will do. Non-intervention, 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 and observation, observation, observation. Let them fail. It's okay if they fail. Keep it safe, obviously, but they will be okay. And then adjust as needed. This is similar to our representing. So we recognize, okay, they're struggling with this, I'm going to represent it. If you've implemented a whole bunch of things at home and you're finding that something's just not working, or it's, it's not turning out the way that you wanted to, that's okay, and be forgiving of that. Your children are changing like minute by minute, so you are welcome to adjust as needed if you've implemented any of these things at home. And then lastly, I don't know if you all thought you were coming in and learning all about the math program in our environments, but this is it. Formal mathematics. I've just kind of broken it down into what we do, and kind of there's a lot to it, but the Coles notes. And if you have any specific questions when we break out, feel free to ask them. But everything that's in the red on the left-hand side, it's under the heading of numbers to 10. Those are those roots I was talking about in that tree analogy. The number rods, as we saw, the sandpaper numerals, number rods and cards is the marriage of the two. The spindle boxes is a material that has little wooden sticks that they count into compartments that are labeled. So again, it's like the marriage of quantity and of symbol together. Numerals and counters, very similar, except we do a specific movement that identifies the difference between even and odd numbers. So it's their first impression that there's a difference between what an even number physically looks like when it's, combined with little counters and odd and even numbers, sorry. And then the last one is memory game of numbers, which is a game that we play with many children where they have a little something beautiful. It's all different in all of our environments, where they can open it. It has a little number inside, and then we tell them to keep it private, and okay, don't tell anybody what it is. And then they have to hold it in their mind. And one by one, they go into the classroom with a tray to go and collect whatever their quantity is. So if their little number says 4, they can walk around and, oh, the 4 pencil crayons. So I'm going to bring 4 pencil crayons. They bring them back, and everybody's like eagerly anticipating, oh, let's count them. 1, 2, 3, 4. You had 4, and then they verify it and show everybody. And it's very, very, very exciting, as you can imagine. But the memory component comes when, if you're, 8th, 9th, 10th, you've really had to hold it in, because we encourage them to only look at that number once. So that being said, we then go into the decimal system. Exploration and memorization of tables is those math facts that we want them to memorize. Passage to abstraction is when they're working with many materials, but they're getting to the point where they don't need the materials as much, because much of the information is already in their brains. And fractions, which is, there's a plethora of things that we do with fractions. I am not sweeping any of that beautiful work under the rug, I promise you. But if there is the number one thing that we can take away from tonight, is that everything that's in that red, if your child comes to Casa and only gets to all of that numbers to 10, they will be better off than if they do half of that and then half of everything else, or half of that and then all of everything else. Because until they have that really solid understanding of what those numbers to 10 are, that's the basis of everything that we do in formal math. So we want them to have all of that practical life and all of that sensorial, so much so, and all of their language, of course, but all of those things, so that when they're working with more formal mathematics materials, their foundation is so strong that they can play with math and they can have fun with math. And it's not this kind of like thing that you either have or you don't. If they've had this experience over and over again, they'll have it because it's been enriched and beautiful and set them up to have a healthy relationship with formal math that's to come. So, so yeah, I think that's everything for me.